for looking at this, we're not done with the problem. Find the equation of the tangent line at the square root x equals the square root of x. Is this the only point on the curve? Now, I'm going to, we need more room for this, so let's get another page here. What do we need in order to write the equation of a line? Okay, so we need, oops, there we need the slope and a point. Let's see, this was at x equaling the square root of 5. Well, do we have a point? We actually have 2 points. So we have the point square root 5 and what? What did we come up with?
4/3 and negative 4/3.
Was it 4/3? Yep, a negative 4/3. Okay. So and we have the point square root of 5 and negative 4/3. Let's go back and look. That's the point here. That's the square root of 5 and 1.33333 4/3, and down here negative 4/3. Okay. Slope. Now, if we're going to do this, define the equation of the tangent line at this point, we need to have, we need to know what the slope is that matches this point. So the slope at x, we'll just say at, let's see, how can we best do this? Well, let's do this. I'll take away that arrow. And let's just say this slope is what? There was the negative portion. That's not the exact answer. What was the exact answer? Okay, so that would have slope of negative square root 5 divided by 3, and this one has a slope of then square root 5 divided by 3. So we've got y equals negative square root 5 divided by 3. X minus its value, square root 5, plus 4/3. This one is now going to be y equals square root 5 divided by 3, x minus square root 5 minus the square root of 4/3, because it's negative. Okay, let's see, y equals negative square root 5 divided by 3x. Multiply these two together. Is that plus 5 divided by 3 plus 4/3? If I multiply the square root of 5 times the square root of 5, I get 5. So I have 5 equals negative square root 5 divided by 3x plus 9/3, which is what, 3? Did we get that as an equation for the other line on the Inspire? I don't think we figured that out yet, did we? No? We can do it though. So we go to Menu, Actions, Coordinates and Equations, point to that. There's that equation. Point to that. There's that equation. Menu, Actions, and Coordinates and Equations. Oh, wait a minute. What page are you on? Graphing page? Be on the, yeah, you have to be on the graphing page. That would not work the same thing. Yes, Aaron.
Oh, sorry.
Oh, okay. Aaron, though, since you volunteered, do we have the right answer? Is this the slope of the tangent line here? Pardon?
Yes.
You sure? There seems to be a question in your voice there. Well, let's see. This is the equation for that tangent line. What's the, is that slope? Let's see here. Let's see if I can get that. That's not going to work. What I'm trying to do is increase the digits on that. I'm not sure that it's going to work unless I go into another menu to do that. I don't want to bother with that. It's not just shading out that slope. So would you believe, Aaron, that that slope of that line is equivalent, pretty much equivalent to the slope we found with measurement?
Yes.
I would believe that too. It's close enough. Okay. And then down here, we've got -3. So if I were to do, let's see, this portion of it right here, I would have the same work. So I'd have y equals square root 5 divided by 3 minus 5 divided by 3 minus 4/3. So I end up with y equals square root 5. There's an x in there someplace. Okay, minus 9/3, which would be then my -3. Now the question says, is there another point on the curve, though, that has the same slope? Is that what it says? Is this the only point on the curve that has this slope? Let's take the slope of positive square root 5 divided by 3. Is that the only point on that curve that has that same? In other words, can I draw a line parallel to that and have it be tangent to the curve someplace?
Yes.
Absolutely. Absolutely. I wonder what that point of a tangency is. You want to take a guess? What you think it might be? Whoops, there's the equation. There's the equation. What would that point of tangency be? I don't think I can get just that point unless I do something else. Okay? Let's see here. If I put a point on right there, if I put a point on there, anyone want to take a guess as to what that point might be? What is it? It was 1.44, wasn't it? No, maybe that isn't going to be as easy as I thought to figure out. Could we do it analytically? How would I determine that analytically? What's the derivative of our equation? This right here? Okay. If I want the same slope as what I have on the other point, I'd have to set this equal to what? The slope, yeah. And so if I set this equal to the slope, what slope are we going to set it equal to? Well, how about negative the square root of 5 divided by 3? So if I take this derivative, there we go, right here, and set it equal to negative the square root of 5 divided by 3, could I solve for x? Yes, I can do that. I can solve for x down there and come up with that. Okay, well, that's one of those problems that if I gave you one problem on a test or a quiz, it would be interesting. Let's just put it that way. It would be interesting. Okay. Okay, I'm going to show you this next problem. Again, we're talking about implicit differentiation. Once again, on any differentiation, what does this variable, this letter, this term right down here, what does that represent? The input. Okay, keep that in mind. It says, find the rate of change of x with respect to p. That's what that phrase says. Got it? Find the rate of change of x with respect to p. Now, let's go back. When we have this notation, how do we read that? Oh yeah, dy dx, but what else? With respect to what? Where's the x? Down there. Hang on to that. What's that say? Okay, with respect to p. Yeah, this is what we're going to have to do. Dx dp. Not what we usually see, not what we think we're going to always see, but this variable right here is the output variable, and this one is the input variable. We read it this way, but we don't often see it in writing. And so we want dx dp. How would I find the derivative with respect to p? This is what we're trying to find now. I'll put a word find up here. We could solve for x. Be a little difficult though, because that's an x cubed and that's an x. So what we can do is what we would be doing anyway, and that is find the derivative with respect to what? P of each side. How many zeros are there? 4. Oops. Why can't I just, I've done this before, why can't I just make this, 0.0000 x to the negative 3 and put it up here? Absolutely, it's not a factor. If it's not a factor, I can't do any of that stuff with the exponent, so I have to keep it down here. So what's the derivative of p with respect to p? If the variables match, it's just, it's a simple derivative. It's just be 1. What am I going to have to do to find this derivative? I've got to use the quotient rule. Okay, that's the first one I'm going to have to use, and there may be others. So let's see, I've got and I found, this is where some students in the other classes lost points. They didn't show me the line of intent, and some of them messed it up. And so I had no recourse but to take some points away. So we've got the denominator. So I have the denominator. Times the derivative with respect to p of the numerator minus the numerator times the derivative with respect to p of the denominator all of that divided by the square of the denominator. Yes?